People usually think that they understand reality, length, width, height, time moving forward. That feels complete. But physics quietly tells a different story. Right now, you are not just standing in space. You are moving through a structure far more complex than your senses allow you to perceive. And according to modern science, the universe does not stop at 4 dimensions. It likely has more. One of them is known as the fifth dimension, and it changes how we understand time, choice, and reality itself. Before this sounds like science fiction, let's ground it in something simple. Imagine a dot. No size, no shape, just existence. That's 1 dimension. Stretch that dot into a line. Now you have length. 2 points can exist apart from each other. Add width, you get shapes, a surface. That's the 2nd dimension. Add height. Now objects have volume. That's the world we live in, the 3rd dimension. For centuries, this was considered the complete picture of reality. Then physics encountered a problem. Time could not be ignored. In the early 20th century, Albert Einstein showed that time behaves very differently from what humans experience. It slows down near massive objects. It speeds up depending on motion. It bends. Space and time, he showed, are not separate things. They are part of one structure, space-time. That realization gave us the 4th dimension. But even that was not the end. Once scientists accepted time as a dimension, a new question naturally followed. If dimensions describe directions in reality, why would there be only 4? In physics, dimensions are not defined by whether humans can perceive them. They are defined by what is mathematically necessary to describe how the universe works. And when physicists tried to unify gravity with quantum mechanics, the physics of the very small, 4 dimensions were not enough. This is where higher dimensions enter the discussion. In several advanced theories, including string theory, the universe is described using more than 4 dimensions, sometimes 10, sometimes 11. These extra dimensions are not imagined as alternate fantasy worlds. They are mathematical consequences of equations that successfully describe fundamental forces. The 5th dimension, in particular, can be understood in a surprisingly intuitive way. In the 4th dimension, time is a line. You move along it in one direction. In the 5th dimension, time is no longer a single line. It becomes a plane. That plane contains all possible timelines that could emerge from different initial conditions. In simple terms, the 5th dimension represents the collection of all possible versions of how events could unfold. This does not mean that every imagined scenario exists in a literal, accessible sense. It means that physics allows for multiple solutions to the equations that govern reality. Each solution represents a different timeline. The idea that reality may contain multiple possible histories is not fringe science. It appears in serious discussions of quantum mechanics, cosmology, and theoretical physics. Physicist Hugh Everett proposed something similar in the 1950s with the many worlds interpretation of quantum mechanics. His idea was that quantum events do not collapse into a single outcome. Instead, all outcomes exist, each in its own branch of reality. These branches are not separate universes floating somewhere else. They are different paths within a higher dimensional structure. In that framework, the 5th dimension can be thought of as the dimension that allows these branches to exist. Stephen Hawking also explored higher dimensional models, especially when studying black holes and the origin of the universe. He acknowledged that the mathematics often points beyond the 4 dimensions we experience. Even today, physicists working at places like CERN study models that include extra dimensions, not because they sound exciting, but because the equations demand them. One important thing to understand is this. Humans are not meant to experience higher dimensions directly. Just like a 2-dimensional being could never perceive height, we cannot perceive higher dimensional directions. That doesn't make them unreal. It only makes them inaccessible to our senses. A useful analogy is a shadow. A 3-dimensional object casts a 2-dimensional shadow. The shadow is real, but it does not capture the full structure of the object. In the same way, our experience of reality may be a lower dimensional projection of a higher dimensional universe. From this perspective, the 5th dimension is not somewhere you travel to. It is part of the underlying structure that allows different timelines and possibilities to exist. Importantly, this does not mean your choices are meaningless. Physics does not say that consciousness jumps between timelines. It does not claim humans can control dimensions. What it suggests is more subtle. Reality may be far richer than the slice we experience. Time may not be a single flowing river, but a landscape, one that contains many paths. and we experience only one of them. This idea has practical consequences in science. Understanding higher dimensions helps physicists model black holes, predict particle behavior, and study the early universe. Without these concepts, many equations simply stop working. So when scientists talk about the fifth dimension, they are not describing mysticism. They are describing the geometry required to make sense of reality at its deepest level. Whether these dimensions can ever be observed directly is still unknown. Some theories predict subtle effects that future experiments might detect. Others suggest these dimensions are permanently hidden from us, but their existence remains one of the most serious possibilities in modern physics. The universe, it turns out, may not be limited by what humans evolved to see. And the fifth dimension is a reminder of that, not as a fantasy, but as a consequence of asking reality to make sense and following the math wherever it leads. Next video will be on something even beyond the sixth dimension.